And apologize again for last time where it seems like my um, internet provider had some issues with my particular system. So that got straightened out, and hopefully you won't have that again. All right. So kind of forgot where I left off in chapter 5, but we're going to cover chapter 5 up to the time of the quiz. We will start the quiz at 8:50, right? And it'll be a 20-minute quiz. And that should give you plenty of time to complete it. The quiz will be fill in the blanks, but I have created drop-down boxes for each of the blanks so that you don't have to actually um, worry about the spelling of the correct answer. You just have to pick the correct answer out of the drop-down box, right? So, but you need your book unless you've memorized everything in those 4 chapters, you'll need your book to look things up. Hopefully, you've read your book so you know where everything is. Don't guess. I mean, you'll have to guess if you run out of time, but don't guess in terms of what the answers are. Just look them up. All right. So let's get to PowerPoint for today. And again, what I'm going to do is go through most of the slides. I'm going to skip the first few, obviously, because we covered those last time, but I'll go over some of the definitions again for chapter 5. Now, the quiz for chapter 5 will be next Tuesday, all right? Next Tuesday will be, let me see, hold on one second. Yes. So next Tuesday will be the quiz number 2, which will cover just chapter 5. And there will be a review for test 1, which will be next Thursday. So a week from today will be test number 1, and that will cover first 5 chapters. All right, and I'll review what's the types of things to look for when you test number 1. Talk about that next Tuesday. All right, let's talk about chapter 5 here. Again, we'll review some things we covered last time. The idea that in an experiment, you're going to have 2 types of variables: explanatory variables, the one that explains or causes differences, and another type of variable, which is called the response variable, sometimes called the outcome variable. Okay. For example, if you have a study where you're determining whether a left-handed person dies at a younger age than right-handed people, then the explanatory variable is handedness. Handedness meaning left or right. All right, that's your choice, whether you're left-handed or right-handed. And then the response variable is the age a person dies. A treatment is one of the combinations of categories of the explanatory variable. And the person who runs the experiment randomly assigns these treatments to the people in the study. All right. So that is called the treatments. All right. Let's get to the next slide. Randomized experiment versus observational studies. So a randomized experiment is where the experimenter creates differences in the explanatory variable. So they're controlling the explanatory variable. They examine the results in the response variable. In observational study, you just observe the differences in the explanatory variable and notice whether they're related, the differences in the response variable. And here's the key difference between these two types of studies. In an experiment, if you randomize or randomly assign treatments to the people in the study, the groups that are created, the experimental groups, are going to be approximately the same in terms of other types of variables. And therefore, you can say with confidence that any changes that are occurring in the response variable due to changes in the explanatory variable is a cause and effect relationship. The changes in the explanatory variable are causing the changes in the response variable. But in an observational study, since you are observing the differences in the explanatory variable and not controlling for other types of variables that could be causing changes in the response variable, then we cannot talk about cause and effect. We can say that there's a relationship or an association between the explanatory variable and the response variable. Maybe we can use the word they're correlated, but we cannot say that the explanatory variable is controlling or causing the response variable. All right, so that's a key difference. All right. Now, what are reasons why we would have to sometimes go with an observational study instead of an experiment? Well, it's because it would be unethical to assign treatments to the experimental groups. All right. I mean, for example, if you're trying to determine whether smoking causes cancer, you're not going to assign people to the smoking group and then say, please smoke cigarettes, right? It's unethical to do that. Sometimes explanatory variables are inherent traits. All right. If you're trying to determine whether whether differences in height causes differences in weight, you can't assign height to people, right? They are born, or not born, but they are of a certain height. That's what they mean by inherent traits. They're traits that you cannot randomly assign. They're part of a person's body. So you can't do experiments when you're looking at comparing people's heights and weights. It's just not possible. Now, the other types of variables which could be influencing or affecting the response variables are called confounding variables. All right, so this is a definition that you need to know. And many times, changes in the confounding variable and changes in the explanatory variable occur about the same time, and you cannot tell the difference in terms of which one is causing the change in the response variable. All right, let me give you an example of that. Suppose you own a coffee shop, right? And you're trying to increase the number of people to come into the coffee shop. Well, you hire somebody and they say, hey, your store kind of looks kind of drab, and maybe you need to hire an interior decorator to come in and make it look better. So that's what you do. You hire an interior decorator, and they make some suggestions, and you go ahead with the suggestions. Now, while the work is being done to make your coffee shop look better, there's a mall that's opening up close to the coffee shop. And it happens to be that when you reopen your coffee shop with the new interior, that mall opens up at the same time. And what you notice is that there's increased number of people coming into your coffee shop. Unfortunately, you're not able to tell whether it's because of the interior decorating that caused people to come in, or whether it's because of the mall, right? So the mall is sort of a confounding variable there. You're not sure what's causing the increase in the number of people coming into the coffee shop. So confounding variables are a bigger problem in observational studies because you can't control for them in observational studies. In an experiment, when you randomly assign treatments to people, what you're going to assume is that the confounding variables are about equal in both of the experimental groups. And therefore, you can pretty much say that they have about the same effect in each group. You can pretty much eliminate them as causes for changes in your response variable. One second here. All right, and here's, again, you give another example here of confounding variables, study of the relationship between smoking during pregnancy and when after the child is born, the child's subsequent IQ a few years after birth. Is there a relationship there? Well, once again, it's possible. If you do see that women who smoke, their children subsequently have lower IQs, well, it's possible that the mother, there's other reasons why the child has lower IQs. Maybe the mother, maybe a person who's, and again, there's no association here. I'm just making this up. It's possible mother who smokes might actually also eat more poorly. All right. They might have lower income, whatever. Don't make anything of this. Just know that there could be other reasons why a child's IQ is lower. All right. It may not necessarily be because of the smoking. Okay, so that's the problem with observational studies, is that confounding variables could be causing the changes in the response variable and not the explanatory variable. Sometimes variables interact. In other words, there's an interaction between explanatory variables, all right? And that may be causing changes also in different types of changes in the response variables. So explanatory variables could interact with one another, all right? Here's an example. Smoking during pregnancy reduces IQ when the mother does not exercise, but raises or does not influence IQ when the mother does exercise. Then we would say smoking interacts with exercise to produce an effect on IQ. You see that idea there? That there's sort of a relationship between smoking and exercise here, right? Smoking, when you don't exercise, smoking has a bad effect on IQ. But if you're smoking and you do exercise, the effect is not as bad, and could actually be better. So there's an interaction between these two possible explanatory variables, smoking and exercise, on the effect on IQ in children. So that's called interaction. Now, if you were taking a statistics class, even an introductory statistics class, we don't go into interaction between variables too much. It's pretty much an intermediate course in statistics that we actually show you how it works mathematically. But in this course, we won't be doing that, obviously. Some more definitions. Experimental units. They're the smallest basic units to which the treatments are randomly assigned. So if it's people, it would be people. If it's fish, it would be fish. Whatever. It doesn't have to be a living thing. Could be an inanimate thing. Observational units are the objects of people measured in any study. All right, measuring people again, or some other thing. When there are people, we typically call the units, whether experimental units or observational units, we call them participants or subjects in the study. And they say here that participants are often volunteers. All right, they're not being randomly chosen by a sample. They probably should be, but they're typically not. And therefore, we can't generalize typically. Many people do it anyway, but we can't generalize the results to a larger population if the participants are volunteers. All right, so let's talk a little bit about some of the requirements for designing a good experiment. One of the things that we need to talk about is the idea of randomizing the treatments. What does that mean? That means that you have participants. Let's say you have two possible treatments. Let me think of a good example. Suppose a school district is trying out a new reading program for their children, but they have an old reading program. All right, so they want to see if the new reading program leads to better reading skills in their children. So the two groups are going to be those who receive the reading program, the new reading program, and the other group would be the ones receiving the old reading program. And if to make sure that the two groups are about the same in all other respects, you randomly assign children to these reading programs. Okay, so that's what we mean. So how do you do that? You typically maybe give every child a number, and then you have either a computer or you just put their names into a box or something, and you just randomly select children that way to be, let's say, in the new reading group. And once that group is filled, all the other children go into the old reading program. Okay. Now, what if we have an experiment where there are people who receive all the treatments? Okay. In other words, it's not It's not that they're being randomly assigned to one person and as opposed to another person, but suppose that some experiments may be designed where one person receives all the treatments over time. So how do you get the randomization in there? What do? You randomize the order in which the treatments are given. All right. So everybody gets all the treatments. Maybe there are 4 treatments. Then you just randomly assign a person for the first treatment to be one of those 4 treatments, and then continue with like that until you get all the treatments. So the treatments are randomly assigned in a particular order over time for each person. All right, so that's another way of randomization. All right, so here's an example here, randomly assigning meditation practice and they want to see, does regular practice of a certain type of meditation enhance the immune system? So what is the explanatory variable? Whether you meditate or don't meditate, right? You have a control group, doesn't meditate, and then you enhance and you want to see what effect is there on the immune system. That would be your response variable. So there were 41 volunteers who were recruited, and they were randomly assigned to the meditation group or the group that was not a meditation group. So they said 25 were randomly assigned to the group that received an eight-week meditation program. 16 were randomly assigned to the other group that did not receive this training. All right. Now, because they randomly assigned, now what are possible confounding factors that could be affecting the person's immune system? Well, daily stress could be affecting. That would be one example of a confounding variable. Okay, some issue here with the computer. There we go. So let's look at some additional definitions that could be involved with a study like this. Number one, a control group. So you have a treatment group, a group that's receiving a treatment, and they're the same in all other respects, except, excuse me, and then you have a control group. So you have a treatment group, the people who are going to receive the treatment, and you have the control group. The control group should be identical to the treatment group in all other respects, except for whether except for the fact that the control group is not receiving the treatment. All right, so in the case of the meditation example, the control group would be those who do not receive the meditation. All right. All right. Many times the control group uses what are called placebos. This happens basically when you're testing whether a drug works or not in reducing the symptoms of a disease. All right. So, for example, that you may, there might be a drug, all right, and the drug, half the people get the drug and the other half get the placebo, randomly assigned. Now, what is the placebo going to look like? It's going to look like the real drug and maybe taste like the real drug, but it doesn't have the actual ingredients of the drug. Okay, so the people who are receiving the drug and the people receiving the placebo, they don't know which one they're getting because it looks exactly the same, it tastes exactly the same when they take it. All right, so they're being randomly assigned both the drug and the placebo to the 2 groups. No one knows, the participants don't know which one they have, and that's called blinding. Blinding means the participants don't know whether they received the placebo or the real drug. Now, why do we want to do that? Well, there's this thing called the placebo effect. It's described in your textbook. And the placebo effect basically is that a person, and even if they know they're getting the placebo, they may still think that it's going to work. All right. They have this. So it's basically mind over matter. And many times they get positive results from taking the placebo. So to negate that effect, we don't allow participants to know whether they're getting a placebo or not. all right? And that's why we have this placebo group, all right? That's not that in terms of not knowing they're actually getting the drug or not. So blinding is a single blind in this case would mean that the participants are not aware of whether they received the drug or the placebo. A double-blind situation would be where the person administering the drug or giving the drug to the participants, they don't know either, because we don't want them to sort of like through body language or something that they say, give away what they're actually giving to the participant. So many times the person who is administering the medication to the participant doesn't know either which one the participant's getting. So that's called double blind. Now you may ask, well, who knows, who's the person who does know whether a person's receiving the drug or not? And the answer is the researcher. So the researcher hires somebody that the researcher knows who gets what, but the person who's hired and administers the placebo and the drugs, they don't know which one is being given to the participants. So double blind is the best type of experiment if you can do it. Single blind obviously is the second best. Now, single blind could also mean that the participant does know what they're getting, but the researcher, or the person administering the drug doesn't know. That's also single blind. But double blind means both don't know. Now, there are certain types of research studies you can't have blinding in. For example, the meditation example that we just talked about. All right. Obviously, the participant knows that they're in the meditation group, right? Because they're being taught the meditation. First, the people who are not in the meditation group, they know they didn't receive the meditation training. So there's no blinding going on in that type of study. All right. The participants are well aware of it, but it's better if you can to have blinding to prevent the so-called placebo effect. All right, so here is an example of blinding. The study basically says which lowers cholesterol more, a special diet or a certain type of drug. All right, so they want to compare these various treatments. Now they have 3 treatments here in the study. So they have the diet, special diet, they call it the portfolio diet. They have the drug case where they say they give a person a low-fat diet with this drug. And then the third case is a low-fat diet with a placebo. All right, placebo. So the 46 volunteers were randomly assigned one of these 3 treatments using a random number generator in a computer. So everybody got a particular number. All 46 people got a number, obviously from 1 to 46. And then the computer selected people to be in one of these 3 groups based on selecting randomly numbers from 1 to 46. All right, so blinding. Who was being blinded in this experiment? All right, it says here that the researchers and the participants were both blind as to which drug the people in these 2 groups were taking, the placebo versus this drug called lovastatin. I guess that's how to pronounce it. However, participants and dietitians could not be blind to what the participants were eating, right? So whether they were eating the special diet or a low-fat diet, it's pretty clear which diet they were eating. The lab staff evaluating the cholesterol measurements were blinded to which treatment the person was receiving. So in this case here, the lab staff were completely blinded to which treatment people were getting. The participants were sort of partially blinded. You could say partially because in terms of the drug, okay, they didn't know the people who got the drug versus the people who got the placebo. Those people didn't know which they got, but obviously the people who were in the special diet group, they knew what they were going to get. So it's a kind of a little more complicated situation. But I hope you understand the concept of blinding. It's basically people just don't know which treatment they got. That's what it means. There are other types of experimental designs that I will just mention briefly. You just have to sort of know what they mean in a very, very general way. You don't have to know how it actually works. There's another type of experimental design called matched pair. So basically, you have two people that are matched. Maybe it's a husband and wife, all right? Or it could be the same person receiving two treatments. And the randomization basically is if it's two people, one person is randomly assigned one of the treatments and the other person gets the other one. Or if it's the same person receiving two treatments, you're randomizing the order in terms of getting the two treatments. So maybe one person gets treatment number 1 first and treatment number 2 second. Another person gets treatment number 2 first and treatment number 1 second. But it's randomly assigned just by, you could flip a coin or whatever, however you randomly assigned it. There's another type of experimental design called randomized block design. This is like the matched pair design, except you have 3 or more treatments. All right. So matched pair design, there are only 2 treatments. All right. And a block design, you have 3 or more treatments where you randomly assign them. All right. That's called randomized block design. A special type of randomized block design is called repeated measures design, where in which the same participants are being measured repeatedly. So the case in the matched pair design where you have the same person receiving 2 treatments and they're randomly, the order is randomly assigned. If there are more than 2 treatments, then the same person would be randomly assigned one of 3 or 4 treatments. That's called a repeated measures design. All right. So again, you just have to know what they mean, nothing more than that. All right. And sort of explained here, explain a little bit in the textbook. All right. So let's see how we're doing with time. We got another 19 minutes. I think I have enough time to finish section. Next section talks about reducing, controlling natural variability and what's called systematic bias. So in an experiment, when you randomly assign people to treatments or treatments to people, what happens? There could be it could be used to reduce unknown systematic biases due to confounding variables. All right, so there could be variables out there, confounding variables that we're not aware of. By randomly assigning people to treatments, or saying it the other way, by randomly assigning treatments to people, what we're doing is we're eliminating the effects of these other variables that could exist and could be affecting the results of the experiment. Randomization tends to get rid of these unknown biases that exist. Matched pairs, repeated measures, and block designs are used to reduce known sources of variability in the response. All right. So any other variables that could be out there that we're aware of, and we can control for, we use these types of designs. Matched pairs, repeated measures, and blocks, again, are being used for variables that we are aware of that we don't that we want to control for. All right. So does that make sense? Random assignment is to get rid of those other variables that we are unaware of. And these other designs, matched pairs, repeated measures, and blocks are used to get rid of other variables that we are aware of. Okay, and then what happens as a result of doing all this? We can say that the changes in the explanatory variable are causing the changes in the response variable. That's the whole idea. All right, so this is just an example here. We have 240 smokers that are recruited for a study. So everybody's smoking in the study. We randomly assign to either, we have 2 groups here, looks like. We have a nicotine patch or a placebo patch. All right. So there are 2 groups. the nicotine patch group and somebody who's receiving a placebo patch. Therefore, there's some blinding here, right? The participants don't know whether they're receiving a nicotine patch or the placebo patch. It's also double-blinded, meaning that the person who's giving the patches out, they don't know which patch the participants are getting. All right, so after 8 weeks, 46% of the nicotine group quit smoking. Only 20% of the placebo group quit smoking. So there was a much larger, over double the number of people in the nicotine group who's quit smoking as opposed to the placebo group. After 1 year, 27.5% of the nicotine group quit. Only 14.2% of the placebo group quit. Now the numbers went down obviously because there were some people obviously who went back to smoking, but it looks like approximately twice as many people quit smoking with the nicotine group as opposed to the placebo group. And since this was a double-blinded experiment, and we were controlling for other types of variables, we could be pretty confident to say that nicotine patches helps people quit smoking. That's really the result of this experiment. There's a cause and effect relationship that we can actually talk about. All right, so what are some types of difficulties that could occur in experiments? Well, here are the list of them, and we're going to just go through them briefly. Confounding variables we've talked about already. These are variables that are connected with the explanatory variable in a sense that they can distort the results because they may be actually also causing the change in the response variable. All right. So that example I gave with the coffee shop, the changes to the interior of the coffee shop is the explanatory variable. The response variable is whether there was increased number of people coming into the coffee shop. What's the confounding variable? The mall opening up. All right, and we're not sure whether the mall opening up or the changes in the coffee shop caused the increased number of people coming into the coffee shop. So if we wanted to do an experiment, we would have to randomly assign people to randomly assign people to either the two groups. Obviously, my example is more of an observational study, right? Observational study. But in an experiment, you would randomly assign people to the treatment groups, and as a result of that, the effect of the confounding variable would apply equally to each of the treatment groups. All right, that's the whole idea. Is we're not getting rid of the confounding variables. We're just saying the two groups have about the same amount of the confounding variable. All right. They gave the example, of course, of the nicotine patch therapy versus the placebo patches. All right. How did we know that the nicotine patch was better than the placebo patch? Because we randomly assigned people to the two groups. And it's possible that there were other factors that could result in people not smoking at home. All right. I mean, not smoking. But doing the randomization, we're equalizing the effects of those other possible variables. All right. Now, here's an example here. They said if we didn't do randomization, all right, and everybody, some people came in as smokers, some people got the patches, some people didn't get the patches, but they were sort of like not randomized. It's possible, it said here, that those people with other smokers at home, all right, people who have other smokers at home may be more eager to volunteer for the volunteer for the study. So treatment would have been this idea that they had other smokers at home. That could have been a confounding variable here that could have affected this result. Because if there's more smokers at home, more likely you're going to smoke also. So the control for that, randomization. Randomization basically The point of that is that the number of people who had other smokers at home would be about the same in both the um, nicotine patch group and the placebo patch group. All right, hopefully that makes some sense to you. Hold on 1 second here, if I went ahead too fast. All right, now interacting variables. All right, this is again when there's more than one explanatory variable that could be interacting with each other. If you don't report this, that there could be interaction between variables, then you could get misleading results, right? So, for example, other smokers at home, there's possible that the interaction between the treatment and whether other smokers are in the home, all right? So let's see what happens here. It says after 8 weeks, the proportion of the nicotine group quitting was only 31% if other smokers were at home, whereas 58% if you didn't have other smokers at home. That sort of makes sense, doesn't it? Because if there's other people smoking at your house, you're more likely to smoke and maybe not quit, all right? Because there's other people around smoking. So without looking at these interacting variables, it could lead to misleading results, right? Because if you go back to the previous results with the smoking example, let's see if I can find that again. They said after 8 weeks, 46% of the nicotine group quit. Well, without looking at these, and that was without looking at the interacting variables. But the interacting variables, at 46% is 31% if other smokers are at home and 58% if not. So you could see that sometimes you need to have an explanation here about variables that interact with each other. All right, and we have to have some sort of explanation in terms of what happens when you have one type of interaction and then what happens when you have another type of interaction. So that's what is being shown here. That interacting variables can obviously have an effect on the results. There are some other types of effects which are mentioned in the book. I don't really go into it that much in terms of testing, but I will mention a couple of these. The placebo effect, obviously, another term of that is the power of suggestion. There's another effect called the Hawthorne effect, which means the results are biased because of the fact that you're just in the study as opposed to being in a natural setting. And there's other cases where it could affect the results, such as the experimenter making errors in terms of recording the results, treating subjects differently based on maybe how they look. All these things could have an effect on the results, all right? So there's other possible reasons why there could be the results that we're seeing. So the whole idea here is that experimentation can be complicated, and you have to really think about what types of things could be influencing the results of the experiment. Randomization tends to take care of a lot of this, all right? A lot of things. And that's why that's the central key part of a well-designed experiment is to randomly assign treatments to people. They also talk about this idea of ecological validity, all right? Now, that's a fancy term, but what does that mean? Well, experiments are typically done in artificial settings, like laboratories or university settings. And even if you get a result, the question is, does it apply to the real world where we don't have an artificial setting? So that's what they mean by ecological validity, all right? They're saying even ecological means environment. So they're basically saying if it's an artificial environment, can we really apply it to a more natural environment in the real world? And that's basically very important. So what is the solution? Design the experiment that can be performed in a natural setting. Obviously, that's not always possible, all right? So that's the point of this idea. All right. Any questions about that idea, ecological validity? It's just a fancy term for saying artificial environment in the experiment versus a natural setting in the real world. All right. And these are just additional examples here. Let me just go over this one here. It says exercise yourself to sleep. Would regular exercise help reduce sleep difficulties in older adults? So let's look at the study here. 43 subjects. This word here, sedentary, means people who don't really walk very much or do very much. They're couch potatoes. So you have these people don't do very much. They're volunteers. They're between 50 and 76 years old. They have moderate sleep problems with no heart disease. All right, so these are the subjects that were brought into the study. And you're randomly assigning them to either a moderate community-based exercise program, or basically the other treatment group would be they continue to sit around and watch TV all day or something like that. So what did they find? They found that the exercise group fell asleep 11 minutes faster on average and slept 42 minutes longer on average than the people who did not get the exercise. Now the question is this a blinded experiment? Is this well, it couldn't be blinded, right? Because the people in the study were either exercising or they weren't. So there's no way for them not to know. So this couldn't be, and obviously the people assigning the treatments knew what was going on. So this could not be a double-blind experiment. The sleep problems were self-reported, but otherwise this is a well-designed experiment because people were randomly assigned to two treatment groups. All right, so that was not a badly designed study. Now, in the book, they also talk about observational studies in this chapter 5. Remember, observational studies are those studies where the experimenters are not controlling the variables at all. They do have a certain type of observational study called a case control study. As far as you're concerned in this course, a case control study, the only thing you need to know about it is that it is a type of observational study. Even though it sounds as if it's an experimental, it is not an experimental study. All right, it says cases who have a particular attribute or condition are compared with controls who don't. So what they do is they have people who are receiving treatments, they have people who are not getting the treatments, but they are not randomly assigned. I'll repeat that. It looks like an experiment where some groups are getting the treatment, some people are in the control group, but it is not randomly assigned. All right. So this is called a case control study. It looks like an experiment, but because there's no randomization, it is an observational study, and you cannot have a cause and effect relationship. All right, you can't prove it. So that's really important to remember, just that little point that I just made, nothing more than that. The other thing is some studies are looked at in terms of when the data was collected. A retrospective study is you're asking participants to recall something that happened in the past. But because of memory issues, people tend to doubt whether the data is valid or not. All right, so retrospective means looking at the past. Prospective means looking in the future. They're followed in the future, and then things are recorded. This is better because people don't have to recall what happened in the past. So the disadvantage of retrospective studies is that they're being asked to recall past events. Now, both of these studies, I have to tell you, are observational studies. All right. The experimenter is not controlling for what happened in the past. All right. And then in terms of the future, the participants are being followed into the future and events are being recorded, but there's no assignment of treatments. All right. So both of these types of studies, retrospective and prospective, are observational studies. So this little slide here is important to remember, because you need to know that case control studies, retrospective studies, and prospective studies are all observational studies. They are not experiments. All right, so please remember that. All right, and then they talk about the advantages of case control studies. You can read through this. There is some efficiency that's increased from them. There could be, when you have controls, you could reduce the potential confounding variables, but the problem is that this is not still not good enough in terms of like an experiment. So it's still not as good as an experiment. All right. And then you should look through this other part here where they talk about the difficulties of observational studies, the idea that you cannot have a cause and effect relationship. You can't control for potential confounding variables. All right. And also, one of the things that you have to realize is that if an experiment has volunteers, then the results may not be representative of the whole population, because the people who were brought into the study were not randomly selected, like through simple random sampling or stratified sampling, whatever. If they were volunteers, you may not be able to generalize your results to the entire population. And that's the disadvantage of experiments. It's many times they are volunteers that are in the experiment. Okay. And then it talks about using the past as a source of data. It's unreliable because of people's inability to remember things clearly. All right. And then this is a very important slide right here, the last slide, the idea that you need to distinguish between random sampling and random assignment. Random sampling has to do with how people are brought into the study. Were they brought in randomly through simple random sampling, or were they volunteers? If it's simple random sampling, it means we can generalize the results to the entire population. If it's volunteers, we can't. Random assignment has only to do with experiments. And the purpose of random assignment is to make sure that you control for other variables, and therefore you can talk about a cause and effect relationship. So please, this last slide here is very important to be able to distinguish between these two terms, random sampling and random assignment. Make sure that you understand the difference between the two. All right, so that's it for chapter 5. That's it for everything we're going to be covering for test number 1. It is 8:50, actually 8:51 now. So go ahead and open up the quiz in Canvas. It should be in this week's module. I have it all set up. Give me Anika and John Bolin and Mark Smeltzer. If you have it open up, give me a thumbs up that you see it. All right, I have Mark giving me a thumbs up. So it looks like you all have it, hopefully. So just open it up and begin. You have, again, 20 minutes to finish, and you should obviously be able to finish before 9:15, unless, of course, you have accommodations, which there may be a different stopping time for you. So go ahead and start. I will put myself on mute. If you have any questions or anything or comments, please send me a chat message. Thanks. And also, please, if you end early, wait for my signal for you to leave. You could just stick around and look at something else while you're waiting.